Hello everyone, I'm Udit Khiraya. Today me and my friend Krishna Chaitanya are going to talk about how we can run the Code Composer IDE, and also we'll put you up to speed about how we're going to install it and run an MSP 430 program on it. So today we're going to have a basic brief introduction of the CCS, and also we're going to talk about the basic installation of the CCS, and you'd also have information about what the MSP 430 exactly does. And at the end of today's session, you could also blink your very own LED using the code provided to you by us. Now I'm going to give you a brief introduction about CCS. CCS is an IDE that supports the Texas Instruments microcontroller and embedded processors portfolio. It comprises of tools used to develop and debug embedded applications. It also includes the C++ compiler, a source code editor, project development environment, a profiler, a debugger, and other features. It provides a single user interface. Now the good thing about CCS is that it merges the advantages from Eclipse and Visual Studio, and along with that it also has embedded debugging capabilities. Now I'm going to talk about the installation of the CCS. Yes. Now the only way we could install CCS is from the official Texas Instrument website. So what we need primarily is a Texas Instrument login ID and password. If you don't have one, you have to make one. So as you get to this page, all you have to do is click on you have to choose whether you have a Linux, or depending on whether you have a Linux or a Windows connection. Small glitch. I'll try it again. Yes. So yeah, you can choose accordingly. Yeah, so based on your operating system, you could choose either Linux or Windows, and then you get to this page wherein you fill in your email address and password. And if you're a new user, you could log in through the right side of the page. Now the thing about this particular IDE is that it needs to be exported from the United States, and it requires an approval. So a lot of details you need to fill in here, and once you do, you can download the installation file. We've already got the installation file up and running. Now my friend Krishna Chaitanya would explain to you how we can go about with the installation process.
Okay, So as my friend was talking to you about the installation procedure, the setup file has now been put onto the desktop. So this is the setup file that you should be looking for. So once you have the setup file, we just open it, and it requires special password permissions. So you enter your password. Yeah, so this is the license agreement. It's very similar to most of the license agreements that you see on when you install many other softwares. So so you click on the accept terms and license checkbox after reading the terms and conditions that have been put out. Right, so now this is basically the folder where you want to install the Code Composer Studio. This folder is generally it's advisable for you to install it in C, but in case you don't have enough space in C, you could always click on the browse button and install it into the directory that you want to install it into. Then once you've selected the directory where you want to install it, just click on the next button. Okay, so we click on the next button, and these are the different options which you can choose while you install Code Composer Studio version 5. And these are all the different devices, these are all the different processors which are supported by this version of Code Composer Studio V5 setup. So basically you can select all these if you want all these, but generally what happens in our case, we're just using MSP 430 low power MCUs, so we are not going to select anything else. But once you select the processors that you need, you just click on the next button, and then these are different compiler tools which would be installed on your computer as a part of this package. And there's also a simulator. So you click on next. This is the total amount of size, this is the total amount of installation size that is required on your drives for the program to be completely installed. Now after you verify that there's enough space, you have to click next. If you feel that there's not enough space, you have to go back and then change your directory. So this installs the GCC tools and the runtime libraries. We just click next. Now this is basically a summary of all the programs that are going to be installed on your computer system as a part of this setup. So once you click on next, it's going to start installing the all the packages that you selected so far. But then we already have such an installation done before, so we're just going to take you directly to the installation. This installation may typically take around 15 to 20 minutes depending upon how fast or slow your computer is. And so I'm going to show you the directory on which it's installed on this computer. So I've installed it on D drive since there's ample space available in D drive. It's installed in the folder TI. So now this is the folder which contains all the packages that we have selected for installation. So CCSV5 is Code Composer Studio 5, version 5. And this is the option to uninstall the tool in case you want to uninstall it. And you go to Eclipse, and then opening this executable application would direct you to the IDE, which allows you to write programs that can be run on all the processors that have been installed onto this particular computer. So now I'll let my friend Udit take over and tell you about how you started the project.
Okay, before I talk to you about what the project exactly does, I'll tell you what exactly MSP 430 is. So MSP 430 is a mixed signal microcontroller family, and it's developed by Texas Instruments, and it's built around a 16-bit CPU, And the MSP 430 is designed for a low cost and specifically low power consumption embedded system applications. Now I'll go ahead and show you what exactly a CCS tool does. Okay, so when you first open the CCS tool, you get this window. You could go about reading what exactly it does about its highlights in the analyzers in the Resource Explorer. Okay, so once you do open the CCS tool, there's going to be a prompt which asks you what kind of license you exactly have. So what we have here is the free 90-day trial. But in case you've bought it, you could input your username and your password. So now I'll show you what exactly is going on in here. So you've got a console. This area is called the console. This is wherein the exact printf statements and what exactly the exact output of your program comes in. And also, if there are any errors and warnings, it could be displayed here. Now I'll show you how exactly we could make our project. So we could go and click on New Project. So what exactly we're going to do? So first we select on a Code Composer Studio. Next. Yeah. So we're going to blink an LED. So let's just call it blink. So what exactly is the output type? It's an executable type, and our primary focus is the MSP 430, as we've told you at the beginning. So there are different variants available for the MSP 430. So we could select the MSP 438. AF253. Okay, this is the location in which we could save our project workspace in. So you could either use the default location, or if you want, which we've selected during the installation procedure, or you could browse and save it somewhere else. So right now we're going to select an empty project because that's how we're starting with main.c. So with main.c, what the difference between an empty project and an empty project with main.c is that we could with the empty project we wouldn't have the main.c function, but presented to you by default. But empty project with main.c would have the main.c function presented to you by default. Yeah, so this is what it looks like when you do select the main.c project. So it's really important for us to first select our view. So we want to see the entire view of our project. So we click on the Project Explorer. Yeah. So this is the Blink program which we've used earlier, and I'll be explaining it to you. Right. So what we have here is our main program, and within it we've defined a variable called I, which is of integer type. So what the first statement here does is it stops the watchdog timer. Now what exactly is a watchdog timer? So what a watchdog timer does in your program is it makes sure that your program doesn't get stuck. So it can get stuck in an infinite loop or any other, or if in case there's an interrupt which occurs. So there are many reasons that for your program to get stuck. So what the watchdog timer does is it prevents that. But for our current LED program, we don't really need it. So we disable the entire watchdog timer facility. Now we're primarily using uh, two ports. One is initialized to 1 and the other is initialized to 0. And we use an infinite loop, as you can see here. And what we're doing right now is this is basically another way of showing an XOR statement. So what you're doing is when you're providing the LED with the value 1, it glows. And when you're giving it a value of 0, that's when it's off. So you want this to happen at regular intervals, time and again. You want this toggling to happen over and over again, right? That's the entire way in which an LED could glow, and you can see it. So this entire thing needs to be within, it has to Yes, so for the LEDs to glow, we need a delay involved with it. So what this for loop here does is it provides that delay so that there's a blinking between the LED. So as we increase this value, the frequency of the LED blinking would decrease. So you would have a larger time gap between each glow. Now I'm going to hand it over to my friend Krishna, who's going to talk about the development environment of CCS. Yes.
Yeah, so the development environment of CCS, basically it starts off with a host computer. The host computer is the one on which CCS is running, and MSP430 DSP is the board that you have on which you want to execute the code. And on the host computer, the platform itself, it starts off with the host computer and the target, and it then adds a real-time foundation consisting of a library of objects which are called DSP or BIOS. And we also have a real-time communication channel which is RTDX. It's known as real-time data exchange channel. So the use of this is in case you want to add some data while the program is running, you don't really have to stop the entire program. Breakpoints can be inserted and signals can be sent to the code as and when necessary. And this functionality was first implemented by TI, and this is the first family of processors to receive such a functionality. And on top of this, you have the program build mode, and you have the debug mode, and the real-time analysis. And the application that we've developed, in our case, we've developed a program to blink an LED. In this, so the application in this context is the program to blink the LED. And we have the Code Composer Studio, which runs on top of all these three modules. And then different plugin tools from various third parties can also be used in Code Composer Studio. In effect, what this does is you can add more functionality to your program. And this is the list of families that are supported by this particular version of CCS. It supports MSP low-power MCUs, C2000 real-time MCUs, Simple Link wireless MCUs, TM4X MCUs, CRTARA, multi-core DSP, and ARM. And now I'll show you how to compile a particular code that has been developed. So initially what we have to do is you need to go to the includes file. Now the project right now is Blink. This is the code which is explained to you by my friend. So first of all, we need to add the path which you can find in properties. And in properties you need to look at the include options. Now the include options basically contains the directory, the path to the include folder, which contains all the header files and other necessary files which are required for the proper running of the CCS4. So in our case, we had installed it in d/gi CCS v5. So you'll be able to find the include folder in a similar path depending upon the directory in which you installed it. So this is the button which you have to press to add a new path. And once this path has been added, you just click on OK, and the system updates itself. So now a new path has been generated. And so our program has already been built, but then you are going to have a symbol here called build, which once you build, binaries are going to be generated, and these binaries are the key to executing the code. And then after, in case we have no errors, then what we can do is you can go ahead and debug the code, and after that it can be run on the board, provided you have a USB connection to it. So yeah, so basically this is the code, and here we have the build option. So you need to so you gotta build, and once you build, you're generally going to get a few warnings. These warnings are related to the interrupt service routines, which we're not currently using in this program, so the warnings can be ignored. And then we have to click on the debug button, and then the debug occurs. Over here we have the no USB FAT found problem. Basically what we have to do is we need to connect the board through a USB to the computer on which CCS is running, and then you got to click on retry. So in that case this error will be solved, and then you can observe the output on the board. The array will be growing. And now I'll hand it over to my friend Udit to tell you a little bit about MSP430 processor.
So we can't exactly show you how the LEDs are glowing. So what I can show you is a diagram. So as you can see, this is a picture of the board, and you find the LED lights in the corner here, and this would toggle on and off depending on the delay you've used in the program, and that can be varied according to the program, as I spoke about before. Yeah, now this talks about the basic MSP430 architecture. Yeah, it's very similar to the other microcontrollers we've used before. So it's got the basic peripherals, the RAM, the flash, and the asynchronous clock and the synchronous clock. And it's also got a CPU 16-bit reduced instruction set CPU, that is. And it's got a watchdog, which I spoke about before. This prevents a program from getting stuck. And yes, that's about it. And this is the end of our presentation here. And I hope you guys learned a lot today. And I hope your LEDs are successfully glowing.
Thank
Thank
you.
you.